begin. In the previous class, we learned that attributes decides the path. The path selection for destinations are not going to be based on bandwidth or delay or reliability or MTU or hop count. It is going to be based on the attributes. Because they are attributes, you can modify them. You can tune it easily. Attributes can be changed. Attributes can be changed. If we teach children, they change their attributes. They change. I was trying to go to the first floor of my daughter's school. My second daughter, who is in the ground floor, she said, "Daddy, breaking the rules. Parents should not go." "No, Daddy." I said, no, your sister is in top. We have to say hi, bye. Otherwise she won't feel good. "No, Daddy, you're breaking the rule. We cannot go this time to our class." See? Attributes. But during the weekends, if we go, she never says you're breaking the rule. But weekdays, if I try climbing the first floor of the school, she don't allow me. That is human attributes. BGP, if you tune as per the policy requirement, BGP will follow your policy in path selection. So we got 4 different type of attributes. We saw actually it is 2 different types: well-known and discretionary. But again, there are some subclasses like well-known mandatory, well-known discretionary, optional transitive, and optional non-transitive. And we learned what they are. But let me quickly revise this portion for you so that the next class we can take next level of understanding attribute. So well-known means it is available, seen in every BGP device. That is well-known. Well-known. Mandatory, it must be there. Discretionary, it may be there. Though it is well-known, if it is there, good. If it is not there also, it's okay. That is discretionary. But well-known mandatory is it must be there. If it is not there, the packets or the updates are going to be discarded. Optional transitive, optional non-transitive. Optional transitive is if it is not present, it's an optional attribute. May be present, may not be present. But if it is not present, still it is considered as an update, but partial update. That is optional transitive. Still it is an update only, but partial update. If it is not considered as update, if it is discarded, then it is called as optional non-transitive. See, under the optional, some attributes are mandatory to be seen, even though it is an optional. If it is not seen, I will not advertise. They are called as optional non-transitive. Even if it is not seen, it is still advertised with a small marking saying this is partial. That is called optional transitive. Let's read the lines. You see, well known, must be recognized, must be present if it is mandatory, may be present if it is discretionary. You see, optional, they are recognized but not by all device. Now, what is optional transitive? If not recognized, they are still valid but marked as partial. Optional non-transitive, if it is not recognized, they are discarded. They're discarded. And we saw there are many attributes like 0 to 13 attributes in the list against which the iteration will be done when an update comes, out of which these 5 attributes are most important for us to know. The reason is these are tunable, using which we can tune the path. The other attributes are dynamic. They're used dynamically in path selection, but these can be tuned to meet our path selection policy requirements, in which AS path, next hop, and origin are well known and mandatory. No updates will be accepted if any one of this is missing. All three should be seen in every BGP update. AS path should be seen, next hop should be seen, origin should be seen. If local preference is not set, it's okay, because local preference, though it is well known, it is discretionary. It is not mandatory. MED is also an optional one. Now, what is AS path attribute? It's an attribute that carries the AS path or AS numbers in the path along with the advertisement. For example, that 192.168.1.0, which is on router A, when it is received on router B clearly knows the sequence. It knows that I need to go to 500, and then from 500 I need to go to 520 in order to reach this destination 192.168.1.0. Because the AS numbers in sequence is advertised. Always the last number in the sequence is the originator from where the network is advertised. The first number in the sequence is the immediate autonomous system number. Secondly, the next hop attribute. As we earlier learned about the next hop behavior, when router A advertises this network to B, B learns with this as the next hop address. When the same network is advertised to C, B will carry the next hop address. It won't change the next hop address. It will simply carry the eBGP's next hop address to iBGP. So when C receives, C will also receive with this next hop address. You have done this lab and you have seen this. If C cannot ping 10.10.10.3, then C cannot use that update. To override this problem, we say next hop self on router B. We say neighbor router C, next hop self. Where do we say this? We say this on router B. Again, you see the previous one is a well-known mandatory, AS path attribute is a well-known mandatory, and next hop is also well-known mandatory. Next is origin. As I was telling you earlier, If I use a network command under BGP and advertise a network, like you did in your exercise, you said network 1.1.1.1 mask 255.255. That is what called as I, or internal to BGP. Before BGP, there was one protocol. The older version of BGP was called as EGP. It is no more, so don't worry about it. And if I'll redistribute, it is considered as incomplete, and you will have question mark. So you see, I have a router learning about 1111 from 3 different sources. This source is giving 1111 with I. This source is giving 1111. Let's say this is a very old router. It runs EGP protocol, not BGP, EGP protocol. Then it will come with E. And you got another router here where we redistribute that 1.1.1.1. Loopback is redistributed into BGP. So it will come like this 1.1.1.1 question mark. Now which one this clever boy will consider? Which one should he consider? He should consider I know, because under BGP we advertise. That is what here it means. I is smaller than E, and E is smaller than question mark. Smaller is preferred. I is preferred. See, the origin, this is called origin attribute. It will explain how it is originated. If I see question mark, I know the story. What is that? Somewhere someone has redistributed it. When I see I know, I know this. Someone has advertised it using network command, not the redistribute. So we can tell the story of how it is introduced. That's why it is called as origin attribute. This is also well known and mandatory. I was telling you the other day, if you advertise a network using network command in London, even in Australia router or Perth, in Perth, you will see I. Even though there may be many autonomous systems in between, it is always carried. Read. The origin attribute informs all autonomous systems in the internet network how the prefixes were introduced into BGP. So this attribute is not local to autonomous system. It is informed to all the autonomous systems, from London to Amsterdam to Addis Ababa in Ethiopia, and then from there to Doha, Qatar, from Qatar to Delhi, India, and then from there to Singapore, maybe down there to Australia, from Australia, Sydney to Perth. Many autonomous systems. It is carried. It is informed. So that anyone on the globe, when they receive, they know how it was added into BGP domain. You see, this is what I mean, this question, sorry, the I everywhere. This I means origin code, how it is originated. This I is different. This I is different. This I is talking about whether it is local to the autonomous system. You see, Local means you will have, wherever you have this 100, you will also see I. Meaning these networks are, these are given by local routers. We'll talk about that in detail later, but I'm not talking about this I. I'm no, when I say origin code, I'm not talking about this I. You should not get confused with the both I's. I is English alphabet, it may be same, but here it is not same. This is origin code I. Origin code I. But whereas this one is simply telling like whether it is local or coming from outside. RIP failure, we'll talk about that later. Rerouting information based failure, that's not a dangerous thing. All right, next is the local preference. I think we have to begin from here in our next class. Any question on what we have covered so far? We have covered three attributes: origin, next hop, and AS path. All three are well known and mandatory. Question, please. I understand. See, this is what you are saying. You see, it is locally advertised using network command, and it is from the same autonomous system. It can be both. No, not all the time. Not all the time. If it is coming from other autonomous system, it will not. You will not have this I. You will not have this I. You will have only this I. If it's coming from other autonomous, on EBGP routers. I mean on EBGP routers. What you say is correct. Mm. Mhm. Mm. Mm. That time, yeah, that time you will not see this I. You will see only this I. But yeah, you will always see this I. But in EBGP router, you won't see this I. If that EBGP router gives to its IBGP router, then you will find this one also. Even in your current topology, you can see this. Any other question? All right, see you.